and welcome to today's webinar, Lawson House Retrofit, Pushing the Envelope. My name is Twyla Neely-Strite, and I'm the Education and Operations Associate at Illinois Green. Today's program was put on by the Illinois Green Alliance Programs Committee, a volunteer group that coordinates the education events covering a wide range of topics throughout the year for the green building industry. The team that organized today's event consists of Jason Meyering, Damon Hedrickson, and Dan Mooring. You've all been muted upon entry, so please type any questions you have into the Q&A and we'll get them answered at the end. This webinar is being recorded and will be sent out in a follow-up email. For those who are unfamiliar, Illinois Green Alliance is a membership-driven nonprofit organization that advances green buildings and sustainable communities for all. Our 5-year strategic plan pushes the green building industry to meet or get on the path to net zero. We achieve this work through education events, engaging communities and partnering with organizations across Illinois, and by advocating for new policies and legislation. Members can view our recorded webinars on our on-demand webinar library. Learn more about membership, see upcoming events, and get involved by visiting our website, illinoisgreenalliance.org. This webinar is approved through AIA for 1 LUHSW credit and can be logged for 1 LEED AP or Green Associate CE hour. Certificates of completion for both AIA members and non-AI members are available upon request. To request AIA CE credit or a personalized certificate of completion for architecture license CE reporting purposes, follow the QR code on your screen and complete the linked form. I'll also be linking the form in the chat and at the end of the session. For those interested in self-reporting CE hours for your LEED AP or LEED Green Associate credentials, we will be sharing self-reporting instructions and a fillable certificate of completion in our follow-up email to all attendees next week through Eventbrite. Here are today's AIA learning objectives. I also want to take a moment to recognize Illinois Green Alliance's sustaining sponsors who make our work possible. A special thank you to our gold level sponsors, ComEd, Resource Innovations, Sloan, and USGBC. Make a commitment to advancing green buildings in communities across the state. Start a conversation about sponsorship partnership today at illinoisgreenalliance.org/sponsorship. Now on to the main event. We have a great lineup of speakers for today's program. Sachin Anand founded dbHMS as a Chicago-based engineering design firm focused on the design of cutting-edge and sustainable projects in the built environment. Educated as a mechanical engineer in his native India, he earned a graduate degree in mechanical engineering from Oklahoma State University. Industry leaders in the building and sector recognize Sachin as both a technical expert in sustainable building systems and a strategic team leader driving ideas to fruition. A sought-after speaker on innovative building and system solutions, he collaborates with architects and others to develop ideas which allow projects to achieve high-level sustainability within the confines of practical budgets. Under his leadership, dbHMS has grown in a decade from a startup to an 80-person firm with projects in locations around the world. Thomas Flynn has over 25 years of experience involved in the planning, design, construction, and management of built environment. His experiences include the design of new and restoration of retail, residential, commercial, institutional, museum, restaurant, industrial, hospitality, and religious buildings. Tom uses his expertise to oversee complex projects as a project manager for Klein Hoffman, involving numerous facade-related components and coordination of construction trades and/or the other design professionals. Tom has been involved with the Lawson House project since 2016. Mercedes Miley is a licensed architect, developer, and urban designer with experience in a variety of project types, scales, and construction methods. As a lover of old buildings, she welcomes the growth and challenges that existing conditions carry to breathe new life into old works of art. Her current work at Farr Associates advocates for bringing sustainable design to a larger audience. Her development work focuses on preserving affordable housing stock in Chicago's South Side. Courtney Perrin is a vice president at CEA&A Associates in Chicago and has 17 years experience in structural engineering and project management. She has designed a wide variety of projects, including the educational facilities, residential office, and retail buildings. She has extensive experience working on existing building structures in addition in renovation projects, including the Museum of Science and Industry. She has been part of the Lawson House design team since 2016. After we hear from our speakers, we'll have an audience Q&A led by architect Jason Meyering. 6-year veteran of the Illinois Green Alliance Programs Committee, Jason works to promote innovative building technology and techniques and the achievements of sustainable practices and projects. Jason's practice focuses on architecture, interiors, and sustainability, and the intersections of living, working, and learning through specializing in education and residential design. Remember to add your questions to the Q&A function throughout the program so that Jason and our speakers can address them at the end. And now I'm going to pass things over to our speakers to get us started.
Good afternoon, everyone. Thank you for the introduction. We are all very excited to share with you Lawson House. It's been in our hearts for a very long time, and so to bring this to a larger audience is very important and special to us. Next slide, please. We were having a little bit of tech issues before we started, so I'm going to give a second to advance the slide. We'll get there. Thank you. So before we get started, I just want to recognize that you're only hearing from 4 of us today. However, there's a huge design team and a development team and a construction team that is part of this project and all large projects of this scale. So a big shout out to everyone on the design team that you're seeing here on the screen. I also had the opportunity to look through the attendee list before we got here, and I know there's a lot of OG people on the call that have been in this project and worked on this project. So if you were involved in Lawson House sometime in your career, why don't you just go ahead and introduce yourself in the chat and what you did in whatever capacity that was. Also, because this building has been around for a while, if you have any memories of it when it was a YMCA or your grandfather used to swim here in the pool or whatever that is, go ahead and drop that in the chat. It always is very interesting to me, all of the people that have been impacted by this project. Next slide, please. So we're just going to take you through like the whole gamut of the building and touch on kind of a lot of the high points, a little bit of architecture, a little bit of the envelope, facade restoration, building systems, and then give you some photos of what it looks like now that residents are moving in. Next slide. Lawson House is referred to as the jewel of the Gold Coast. I don't know where it got that name, but we're sticking to it because we all love it. Next slide. It was originally built in 1931 in the middle of River North. It's the largest SRO building outside of New York City. And it was built as kind of in a place where Chicago grew up around it. People that have been on this project before, mentioned that this was like not the best part of town, but now it's super prime real estate. Next slide, please. More specifically, we're here on the corner of Chicago and Dearborn. If you're familiar with this area, One Chicago or the Billionaires Tower is directly south of the site where that parking lot is currently shown. And so there's just kind of a lot of development that's been happening in the last 10 to 20 years. And then Lawson House has remained in the same location. Next slide. The YMCA was the headquarters in Chicago. It was built in 1931, financed by Victor Lawson. He was a journalist and newspaper man. And he wanted to give the concept was a city and a block. And so if you were a bachelor from overseas or someone who wanted to move your family to Chicago, the YMCA was considered a respectable place to go and make a landing while you looked for work and more permanent housing. And it had everything inside of it. So it had a cafeteria, a theater, athletic facilities. It had lounge spaces. It had a barber shop. You could put your dry cleaning outside in the hallway, and someone would come and pick it up and then deliver it back the next day. So it has all of these crazy spaces, which then we got the opportunity to figure out how to rehab in the 21st century. Next slide, please. So just to give you kind of a big picture of what we're doing, the building has 583 sleeping rooms. Those rooms did not include cooking facilities, and only some of the rooms included their own bathing facilities. Most of that was located either not at all in the case of the cooking facilities, or down the hall in kind of communal style bathrooms. So now it includes 409 single room occupancy units with a full kitchen and a bath. Some other kind of key components to the renovation. You used to egress off the building on the north side from these fire escapes, which was really fun. And you can imagine like, oh, the building's on fire. Let me escape the building. And then there's just like this metal grate that you egress out onto. So we got rid of those and installed 2 new egress towers. And then the tower there in the center is the elevator tower with an elevator that now goes to all of the floors. And then Tom is I'm gonna save all of the historic restoration stuff on the outside for Tom a little bit later. Next slide. This video isn't working right now, but I'm gonna drop in the chat some videos if you just wanna get a look and feel of how the project kind of went through the restoration project. These videos were done by Walsh Construction, the contracting partner. And so they did a just phenomenal job in kind of documenting the project. And so if you wanna learn more, their YouTube page is a good place to start. Next slide. So fast facts, there will not be a pop quiz, but you are free to take notes. The building's 93 years old, 25 floors, including 2 sub-basements, gross square feet about 250,000, over 1,000 windows. That will come up later, 14 roofs, and then 409 units. Next slide. This project, as you saw in people with the introductions, I've been working on this project for 6 years. When I came on board, it was already at 50% CDs. Now I'm considered the OG of the group. So I don't know what that says about everyone else in my presenters. Love you guys. Next slide. The design team originally did just like a ton of research. You know, they taped out how the units would look on the floor so that people could stand in them. They did historic documentation of all of the different rooms, built models, had on-site meetings, interviewed residents. Next slide. Some of those residential interviews are on the screen today, and kind of synthesizing what people said, you know, in kind of a very human term, right? Of I can't control my heat, it's always cold in my unit, and kind of taking that into design, and what does that mean from a thermal comfort standpoint and also a user control standpoint? And how can we translate these folks' real experiences into something that the design can be proud of and then really give it back to these tenants? So next slide. You'll see this diagram twice. The building is very large, so it doesn't work, you know, on a landscape format here. So we've kind of snipped it down so you can see a little bit of everything here. You have residential units, obviously your circulation, some office space, tenant amenities. It all needs to fit into the existing footprint. And it also all needs to be able to have, for the 4 different kind of users of the building, people need to arrive at the same entrance, go up into the elevators and the common areas, and then kind of disperse from there. And so that experience, depending on if you are a staff for one of the social services, or if you're a tenant, or if you're a maintenance employee, is a little bit different and a little bit unique. And so that kind of all needs to nest on top of each other in a very interesting floor plate that, you know, does not pancake at all. Next slide. And then in the units themselves, the design team really did a deep dive into what does 150 square feet look like. You know, in a typical building, you move the wall an inch and, you know, okay, no big deal. That's like a plus or minus on the plan. Here you move it an inch and it's 5% reduction in living space for a resident. And so that's a huge deal. And trying to understand, you know, what is the furniture that's going into the space, the kitchenette. There's 2 different types of kitchens throughout the whole building, one that's accessible and then one that is a type B type unit. And, you know, making things standard where we could in order to best fit into the very unique floor plan that we had. And so the design team in the beginning did a really good job of kind of getting into what that unit looked like with the little square foot that we had per space. Next slide, please. All right, so Farr Associates is very dedicated to prototyping the future, and we are very interested in creating sustainable buildings as our baseline. And so because of that, you can see the 3 different high performance rating systems on the screen. The building was designed for LEED Gold. We're pushing for platinum. We have 1 point left that we are not done with. So if anyone wants to brainstorm about that last point, what it could be, let me know. Back in 2015, when the building project started, Living Building Challenge and FIAS did not have grading systems that really responded to renovations. So this project was part of a pilot program in order to kind of facilitate and push for the renovation of buildings and what green systems look like in old buildings. Next slide. And I'm going to turn it over to Sachin to talk about energy and water.
Thank you, Mercedes. So I'm going to talk about energy and water here, and I think the way I've organized the slides here, we're going to talk about some of the information which we ended up with in terms of how the building systems are, but also talk a little bit about the story in terms of how we got there, what else we looked at, what were some of these the ideas along the way, and then hopefully that's helpful to folks as other folks are working on projects like these, which are renovating these older jewels. So next slide, please. So I want to start off with where we ended up with our energy pie. So you can see on the right what our baseline is, and to put this in context, the EUI for the baseline is 95 kBTUs per square foot per year, and the proposed is 57. So it's a 40% reduction there. And on the next slide, if we go to the next slide, you kind of start to see how this breaks down, and really. Kind of expected in a lot of ways. When you have a residential building like this, the main drivers of energy are heating in a cold climate and the service water heating, and those generally drive these. This building luckily does not have the very high window to wall ratio, so that helps, and we'll talk a little bit more about the envelope improvements in a little bit. So and those are what drove the reduction in the space heating, also with more efficient equipment, and then also on the service water heating, which is your domestic hot water with high efficiency equipment. And then some of the other items, you can see the lighting at the bottom. Some of you will notice a smaller space heating piece at the bottom. So that's the electrical heating. There's a little bit of electrical heating in certain parts of the building, like vestibules and things like that, or back of house spaces. So that's why you have a second bar at the bottom, the third from the bottom there, for space heating as well. So really what the building has in terms of systems is a fan coil system, and I'll talk a little bit more about it in a little bit. We've got a 2-pipe fan coil system for the residential, and for the common areas, we have a more standard VAV system. Some of the unique spaces, we actually have some fan coil units as well, because in a building like this, which was originally designed with no air conditioning, trying to getting air conditioning in it can be very challenging and difficult for those of you who work with a older building like this. One of the other stories which I remember from the project is trying to get upgrading the power and the Commonwealth Edison wall, which is underneath the sidewalk on the street. So that was quite a task, getting that through on this project. So moving on to the next slide. Very early on, we did a quick radiation analysis, and you'll see some of the other analyses here coming up on the slides to follow. And we're really trying to understand, where our opportunities are, where we have solar radiation. Are there opportunities with solar energy, renewables, how we can optimize the window replacements and things like that, and that's really what we're trying to do here. So next slide. So talking about water real quick, you can see where the savings are and how that water pie kind of broke down. We looked at their current water usage. What I don't have a slide here for, we also looked at how to potentially using gray water, rainwater, all of those ideas were explored. But at some point we have to reconcile with the budget and the return on investment. So some of those ideas didn't quite make the cut. Next slide. So this is a slide from very early on during the integrated design workshop we had with the entire team. And we looked at different mechanical systems. And I'm going to spend a couple of minutes here. So the bars represent the energy cost, whereas the EUIs are on the side. So you can see the first option there is fan coil units with VAV. So the fan coil units would be in the residential, the VAV would be in the common areas. And then the next one is fan coil units with chill beams in the common areas. The one interesting option is that third bar, which we looked at, is putting radiant heating and cooling in the residential. I don't think I've seen that before on especially cooling side of it, radiant heating. There's a lot of older Chicago buildings with radiant heating in them. So that was an interesting option we looked at. And then the last one is the more traditional water source heat pumps. With radiant cooling, humidity control becomes key. The advantage there was these rooms, the space, the individual dwelling spaces are fairly tight. So if we put a radiant ceiling panels in here, we could actually save that space which a vertical fan coil would take up. And also it performed better. Also, in order to control humidity, we were delivering fresh dehumidified air directly into each of the dwelling units. So it's got a better indoor air quality inherently in that system type. There was a substantial premium for doing that. We tried looking at it. The contractors were involved early on. It was a very collaborative process, but unfortunately, we couldn't make it. Also, the return on investment there didn't quite work out. So if we go to the next slide, you'll kind of see these options. So this is a diagram we put together early on to kind of explaining the concept to the folks. So that if you look at the four images on the right hand side, the top two are two options: the option A and option B for residential units. So you've got the fan coil and the radiant option. And then the bottom two images are for the common area. So we've got a VAV option, and then we've got a chill beam option. So you can mix and match. So for example, you could have had option A and option Y, or option B and option X. So you can mix and match that, and that's kind of how we looked at this, evaluated these options. One of the things we've realized is when we put diagrams like these, it helps folks understand in a conversation how systems work. So next slide. So things are pretty tight in this building. When you work on an older building which didn't have the modern systems in it, it gets fairly tight. And the next few slides kind of talk about it. This is a modular air handling unit, fairly packed. We had to break it down to bringing it into the building. Next slide. Again, a tight squeeze, and we're trying to make sure there's enough space for maintaining and operating these systems. And that's key to kind of the long-term health of these systems. Next slide. So the next slide is an interesting one. This is where we compared those three residential systems. We looked at the fan coil unit, the water source heat pumps, and the radiant, and you can see some of the numbers there. We kind of started to look at it. You'll see the first cost numbers with the radiant were fairly competitive, and this was our estimate. And when we got the contractors involved, those numbers were greater, and there were other concerns with the radiant system. So we ended up not with the radiant, but with the fan coil system. So it was a good exercise, kind of working our way through this and seeing what we could achieve. Next slide, please. So moving on to some lighting analysis. Very often we do daylighting analysis on new buildings because we think there's an opportunity to, adjusting the massing, adjusting the facade. But you would wonder, why would we want to do daylighting analysis on an existing building? And really the purpose here is these three slides, which you can see here. With the first one, with the annual sunlight exposure, it's talking about the red dots represent where you would have have a potential for glare, which is of course on the south of the building at the bottom there, and on the west to the left of the image. And we're trying to fine tune where this would be. Of course, with glare in a building like this on a typical residential floor, you're going to have shades in the building, so you can tackle that. If we go to the next slide. So that talks about the spatial daylight autonomy, and you can see where the gray dots are. It's kind of really on the inside of the building, and that we use that to kind of working with the architecture team to seeing if we could place elements of the program which are back of house, like electrical rooms, like bathrooms, things like that, where daylight was not as key. So that's how this analysis informed that. And then the last slide here, next slide, please. Again, we're trying to fine tune our daylighting analysis. Next slide. So with an SRO, it's kind of hard to compare this, in terms of for lighting power density. What do you compare it to? It's not quite a hotel. It's not quite an apartment building of sorts. It's kind of when we set an initial target for the lighting power density, we had to look at we kind of made an assumption. We said that this was closer to a hospitality rather than a apartment, and so we kind of grabbed that as our baseline, and then we established a design target, and then we designed all of our lighting to that. And as you're all aware, over the last several years since this project started, LED lighting has come a long way, so that kind of worked out in our favor, and we were able to realize some of those savings. I think that was the last slide of my portion here. I'm going to hand it off here.
Thank you, Sachin. Go to the next slide, please. So early on, the design team did a lot of just thermal imaging and worked with dbHMS and Sachin's team in order to kind of understand the modeling of the building, the energy modeling of the building. And so these are just some of the photos that they took really early on. And you can see just the disparate kind of conditions across the whole facade. Yeah, there's 4 sides to the site, but there's like a bazillion sides to this building. Next slide. And so if you're thinking about a tenant in an individual unit, how can you try and provide like an across the board experience, whether you're located on the west side of the building or the south side of the building, on the 19th floor, the 6th floor. And so what we're looking at is kind of a holistic approach across the building in order to bring the whole building up in energy efficiency wise. And so I've kind of just listed a little bit of the systems there off to the right, the building components off to the right. Roof and R32 roof assembly. There's also a green roof on the 19th floor, partially occupied, partially not. Walls, we have a couple of pictures coming up that shows spray insulation and how that impacted the walls, and kind of bringing it up from a masonry building to a more dynamic envelope system. Operable windows needed to be had in all of the units, but then how do you try and get the lowest U value possible for those windows that also have historic profiles and also have custom profiles? So like that, wow, expensive, talk about expensive, and then consideration to the historic spaces and individual user control. Next slide, please. So what that means in practice is some of the spaces, which are historic spaces, for example, this is the laundry room in the basement, we left as is. And so we tried to return it as close as possible to the original condition. The black vitrolite, the original plaster ceiling, pretty much everything except the floor and the sprinkler pipes are the original condition, and return that and kind of save that and treasure that. Next slide. And then everywhere else, we are like, all right, let's go improve this envelope. So the left side is the existing wall assembly. We have, I think it's a Sears catalog, or it's not Sears, but we have kind of the original catalog for this masonry unit that they don't make anymore, called Unibacker. So that's kind of an interesting assembly. And then on the right-hand side is where we ended up more or less as far as the existing envelope and upgrading that to be an R31-ish, R32 system. Next slide, please. And then all of our FIAS folks on the team drawing your lovely thermal envelopes. That is very difficult when you have a building that has as many corners and as many openings as this, but the design team did a really, I think, bang up job in trying to get that done. And you know, every detail looking at how can you continue that barrier from inside to outside, you know, across the whole envelope system. And again, we did it where we could. There were some spaces where it's a historic condition and we couldn't put any of these interventions in. But you know, where we could, we did all the right things. Next slide, please. What does that look like in practice? These are some installation photos of that spray foam installation. Our details also had originally rigid board going 2 feet on the slab. And that was meant to break down because of how the concrete works, the thermal bridge from the inside to the outside, or sorry, from the outside to the inside, there we go. And so we had a rigid board installation kind of stuck to the underneath side of the slab in order to reduce that transfer. The contractor said, well, you know, we're kind of already spray foaming. Can we just like keep spray foaming and just keep going? And it worked out the same thermally and actually was cheaper. So we said yes, and that's what you're seeing in these photos. Next slide, please. All right, handing it off to Tom to talk about the exterior.
All right, thank you, Mercedes. So as has already been explained, the building, even though it's square or rectangular in plan, there's a lot of offsets. There's, if I counted right, 47 unique drops where we hung swing stages from to perform our inspections and for the contractor to perform the work. The building also has a variety of building materials, brick, terracotta, stone, granite, and cast iron spandrels. There's also stone spandrels that look like cast iron. So sometimes it was hard to tell from the ground which one was which. Next slide, please. Here on the right-hand side is the details that were developed. This is at the courtyard side of the building, so the secondary facades. The what had happened, and you'll see in some of the later photos, originally the courtyards all had hung terracotta window heads. At some point prior to our involvement, those terracotta heads were replaced with brick, where they added a lintel above the window, and then you have 2 courses of brick, and then the shelf angle right above that. So it's kind of an odd little detail to have that much supporting angles in close proximity. On the left-hand side is one of our inspection sheets. This is the courtyard. The red shows where either shelf angles or steel lintels were replaced. And the blue is a corner rebuild, and then there's some other, you can see the key at the bottom, some of the other repairs that were designated as we inspected the building. If you go to the next slide, that'll show kind of the initial conditions that we encountered. Let's see, we'll start in the bottom right corner. You can see there the brick that's slightly discolored above the window opening. That was a replacement brick. Again, like I said, that was originally a terracotta window head. You can see even that new brick is spalled, likely indicating in that circumstance that the steel shelf angle was deteriorating, causing some pressure that caused that brick to explode. Also, you could tell the mortar joints there are not fully bonded. The other photos, you see kind of similar conditions in the top left and bottom left. Some, I don't know, temporary repairs, I guess, where they put sealant in the mortar joints, probably caused more damage. And then on the right, our top right picture, you see again some mortar joints at the shelf angle that are starting to pop off the building. You also see in that top right picture The corners, some of the corners were rebuilt before we started. And they did add an expansion joint at that corner, so we didn't have to reinvent the wheel at a lot of the corners. Next slide. This is the post-demo photo. So we had identified from the previous slide some of the areas that we needed to open up. And this is what we found. On the top left photo is a pretty good history of the building. You can see the lintel over the window opening, and then directly above that, to the far left of that picture, is the shelf angle that has been cut. I don't know if we have a pointer, if that would help. But and then you see a gap, and then at the far end of that photo is the other end of that shelf angle. In between, you could see the rectangular clip that has the two welds on it right in the middle of the photo. That was intended to support the shelf angle. So now these conditions, most of those shelf angles are cantilevered or unsupported at one end or the other. The bottom left picture kind of shows the same thing. When they put the new lintel in, they put the brick and flashing and turn bar, and then cut out the shelf angle. You could see the clip at the right side of that photo above the window. These other two photos, the top right photo shows the condition of the steel shelf angles. At the far right of that photo, you can see there's kind of severe deterioration. And part of that was there were J-bolts at the window heads, and those J-bolts, I assume, were failing. So they took those out, or took out the terracotta and J-bolts, and then put in the brick system. And then the bottom right is the kind of a clear photo of where that clip is supporting the shelf angle, so that about 2-foot section to the right of the clip angle is cantilevered. The other thing we learned, that the concrete that you see there is not structural. It's part of the fire protection for the beams. So all those shelf angles needed to be connected to the steel frame at the clip angles. So we ended up replacing quite a few of those clip angles. Excuse me. Next slide, please. And then here's the finished project. We did, in some cases, just because of budget, left the brick in place. You can see the top right and top left, or the original brick replacements above the window, the two courses. The bond beam above was replaced, or the soldier course, I mean, above that. You can see the new flashing and the weeps. So all that was newly constructed. The bottom left shows a good new window head. The brick matches a little better in our opinion. And then you can see how the soldier coursing was done to match what was there originally. And then the bottom right is an overall shot of an in progress. The first, from the corner on the right to about 3 or 4 window bays, is completed. And then you could see some pretty big holes in the building where they're still working on that portion of the building. Next slide. And I think that's it. I will hand it back to Mercedes or Courtney.
Hello, everyone. So can we go to the next slide, please? So Lawson House was built in the 1930s, and here we have some of the historic photos during the construction of the building. So the structural system is made up of a steel frame of columns and beams with a concrete pan joist floor structure. Next slide. One of our main structural items for the project was to add the new stair and elevator towers to the building. So on the right side, we have some of the existing building plans, the typical tower plan, and the podium level. And The idea for the new towers was to add them to the exterior of the building in the courtyard as independent structures. So you can see that in the construction photo on the left. And then we would feed that structure down through the podium and ultimately transfer into the foundation. Next slide. So we have some historic photos here of some of the large volume spaces in the building. And because of some of these longer spans, we have a lot of transfer structures where the columns sit on these large plate girders. And we have one of the elevations of the plate girders here at the top of the screen. So it ended up that the new structure for the stair and elevator towers were going to end up falling directly on top of these plate girders. Next slide. So these are some of the photos during construction of the plate girders. So they're about 9 feet tall and they span about 55 feet across the whole length of the north half of the building. And we needed to add a corridor through this plate girder to get the egress path to work for the new residential units. And so the architectural solution was basically just to cut an 8-foot tall corridor into this 9-foot tall piece of structure. Next slide. So, you know, with opening that large in that structure, it's obviously not going to work anymore to carry its original load. So we considered a lot of different options, but one of the ones that we took the furthest was to do a full replacement of the plate girder with these new custom trusses. And that gave us a lot of flexibility that we could design the truss members around the corridor. We could pass mechanical ducts through the web members of the truss. But the big downside of that option was the amount of shoring that was going to be required. So in the elevation on the right side, you can see the plate girder is what's shaded in gray. And in yellow is shaded all the 5 levels that would require shoring when they did the demolition of the plate girder. So next slide. So ultimately what we decided to do was create sort of a hybrid of a truss and a plate girder and reuse the original plate girder in its place and just add reinforcement to it. So we have some images of the analysis model that we went through, and we added new continuous top and bottom cord members, and then some angles on the web to make that truss action. And then we reduced the shoring, as you can see on the image in the right. We reduced that shoring just to the bottom 2 levels. Next slide. And then finally, we just have some of the images during construction. So the top middle photo, we have the shoring that's actually hanging off the top of the plate girder itself. And then the hanger rods go through the slab, and then they support that existing slab from underneath, which you can see in the photo on the left. And then the photo on the right just shows the mezzanine framing that was hanging from the plate girder. And that's just a more like a traditional post shore. And then finally at the bottom middle 2 photos, we just have some of the reinforcement members that were installed along the plate girder. Next slide. And I think that's it for me. So Mercedes.
Thank you, Courtney. I will go really quick in these last couple of photos. They're just showing you a little, we've talked a lot about the building components, and so just want to wrap up and kind of end on the residents and their experience in the space. Starting in the lobby, it was very important to the client to have a look and feel that was similar to a hotel. So even though you may be coming from, somewhere institutional, maybe off the streets, from another housing project, you really felt like you were coming home at Lawson House at the end of the day. And so this is the lobby before. And then if you go to the next photo, please, this is the lobby during construction. you know, the first floor is also a transfer point for all the MEP systems. So you have a historic plaster ceiling above in that photo that we can't damage, but somehow have to hang all of this plumbing and mechanical work from somewhere. So that was a really fun coordination effort on the first floor with the dbHMS team to get that to work and still kind of keep that historic ceiling above. And the next slide, please. But you don't see any of that. It's all buried beneath this beautiful ceiling. And this is the new lobby as you enter in off of Dearborn Avenue. Next slide. The original residential corridor, again, as Sachin had mentioned earlier, didn't really have a lot of the building systems in a place that was inaccessible to residents. So a lot of these had been tampered with at some point or were otherwise damaged. And so if you go to the next slide, please, showing that process through construction, we maintained the historic volume of the space, which was considered a historic primary space, demoed out the walls though, because they were really nasty, rebuilt them, reframed them, added all of the building systems in, and then finished out the corridor with some nice bright finishes. And then if you go to the next slide, you can see that full transformation there. And then finally, just the sleeping units into the SROs themselves. So on the left side is about an 80 to 90 square foot unit. Smoking was allowed in this building, and you can really tell from this photo. And then on the right-hand side is a finished unit. And I think that's our last slide, if you just want to go to the next one. So thank you so much. We'll go to the questions, Jason.
Thank you again, everyone, to the team for this great presentation, and thank you for all your years of hard work to preserve this building. It turned out really well, and congratulations on just achieving your substantial completion last week. So looking forward to seeing more of this building in the future. We had a couple questions come in about installation. So there was one question that you had answered, Mercedes, about whether it was all spray foam or you used board installation in some spots. Maybe you could address that again. And there was also a question about the facade, and then it calls for insulation was added to the interior side. Was there any concern about damage to the exterior brick of the facade elements due to the freeze-thaw cycles and the facade being thermally isolated from the interior?
I'm going to have to punt on that second question, unless Tom, you know it offhand, but I can look into that. But the first question about spray foam insulation, yes, we did end up going with spray foam throughout most of the building. There were very few applications where we did a rigid, just because there was something historic beyond that we didn't want to permanently plaster spray foam insulation over the top of. So the idea being that you could, if you wanted to in the future, kind of demo out that rigid insulation board and, you know, just toss it away and you would have that cornice or whatever it was behind.
The other part, freeze thaw is always a concern. The original building did not have any flashing. All that steel was uncoated steel. So part of our work was installing flashing. If you saw the photo, we replaced, I think, nearly 100% of the shelf angles and installed flashing. So the idea is to get water out of the wall system to minimize any impact from freeze thaw.
Okay. Maybe this is a good question for Sachin. What specifically is meant by good IAQ for this project? What were the metrics you used? How do you measure it? How do you control it?
So I think it's a good IAQ for any project, you know, is something, you know, which needs to be defined, and there's different requirements out there, and you know, for this project, we were really following ASHRAE 62.1 and the requirements in LEED, which are kind of most of those are coming through from 62.1. Of course, the Chicago code kind of plays into it. So I don't think if I remember correctly, I don't think we did the increased ventilation requirements. We stuck to the 62.1 because it's always a balance between energy use and how you do. So to me, I think the direct answer to the question is it's 62. ASHRAE 62.1. There are other projects we can talk about broadly. I think that one of the things with the radiant system, which I talked about earlier, is your typical Chicago apartment building till recently you would put fresh air in the hallway, and then it kind of seeps through the door undercuts. That's what we've been doing for decades in Chicago. Not ideal. We all know that, and there's cost complications with doing something different. And I think with the radiant option we looked at, we actually had fresh air being delivered directly into each apartment, and that was the improvement there. So yeah, hopefully I think I've answered the question there.
Okay. Maybe another additional question this evening was about proposed water conservation measures and why several of them were considered and ruled out. Maybe what water conservation measures were considered during the project.
Sure. I mean, we looked at the standard stuff, which most projects do, which is low flow fixtures, and things like that. But and then we looked at rainwater harvesting. We looked at the gray water system. I think we also looked at some of the black water systems. There was some conversation during the original integrated design workshop for a anaerobic digester kind of system where we could treat the wastewater on site. So those were all considered. One of the things we have to remember, and we've put in some of these systems on other projects. I think there's two things which don't work for us here in Chicago. One is the cost of our water. We don't pay a whole lot. It's gone up over the last few years, but we still don't pay a whole lot. So the return on investment on these systems is challenging, one. And two, I think we also have to identify, I've been doing sustainable buildings for 25, 30 years now. In what I've learned is when we overcomplicate things in buildings, over the long haul, those systems, those gimmicky systems we put in don't always work. So who's going to maintain those systems? If we put those systems in, are they going to get maintained? Are they going to get bypassed? So those were all parts of the conversation with ownership, with the Holstein team, along with the return on investment. And in a building like this, the last piece of that is, space required for these systems, and considering how tight all of the spaces are. Mercedes showed you an example of the ceiling in the lobby. So with all of that in mind, we ended up not pursuing several of those ideas.
Okay, great, thank you. I'd encourage everybody to check out the chat. There's some great conversation going on there also about exterior insulation, and Scott and Matt have been sharing some insights and links. I think this is our last question for today that we received. From a cost perspective, what's the difference between rebuilding using existing sustainable approach versus the bare minimum? And two, was it cheaper to overhaul the building versus building a new?
Yeah, I can take a stab at that. So, this will be a very interesting project as we close out. We had our last OAC this morning, like 2 hours ago. So I'm very interested in doing some kind of post-construction analysis, especially in relation to cost. If you've heard Bonnie McDonald and Doug Farr, my boss, kind of go back and forth on whether or not the greenest building is a new building or if it's an existing building, that's a very interesting conversation that happens in the historic world. And what does preservation mean? So I would definitely invite you to check out that conversation has been had a couple of times in different spaces, but is very interesting. In regards to cost, Holston is required to hold the building. Their deal with the YMCA was, I believe, for 50 years of affordable housing, and then their loan goes for the first 15. So when you talk about an owner structure that is going to be in the very long term, and also on top of that, ComEd allowed this project to have a single meter because of the occupancy of the building. So instead of having 409 individual meters, Holston is paying the entire bill. They also pay, for all of the water, all of the utilities. And so when you kind of couple that, it may have cost a little bit more during construction, but then it's kind of paying them dividends over time with that improved efficiency as well as decreased maintenance for a lot of the systems. And that goes back to what Sachin was talking about. And then the second part of that question was tearing it down, I guess, and building a new building, which I guess you could do, but then at a certain point, we have to recognize that we're losing a lot of our cultural heritage if we start doing that.
Great. Thank you again to our panelists. I'll hand it back to Twyla to close us out for today.
Thank you all so much for joining us today. Thank you to our audience and to our speakers. And we will be sending out a follow-up email after this to share information about self-reporting and AIA reporting requests. We've also just dropped a link in the chat for a feedback survey. If you have a moment to share your thoughts with us, we'd love to hear them. Thank you all. Thank you, speakers, and everyone have a great day.